Hello students, today we start a new module number 3, trigonometric leveling in a subject surveying, subject code 3140601. So in a module number 3, we discuss about the leveling and instrument used to find out the different points level. So here in a trigonometric leveling, is a process of determining the different elevation of station from the observed vertical angle and known distance is known as a trigonometric leveling. So here we determine the different elevation of station. So in all the instruments we set up the instrument is known as a station, but here in a trigonometric leveling we put the staff for a leveling purpose is known as a station. Clear? So here the vertical angle are measured by means of the theodolite and horizontal distance may be either measured or computed. So here in a vertical distance is measured by the vertical angle. At a horizontal angle we set the 0 degree and fix the screw in a horizontal direction, but in a vertical direction we rotate the telescope in a upward and downward direction as per our requirement. So like if the station in upward side, so we rotate the telescope in a upward direction, and if the telescope in a downward direction, if the station in a downward direction, so we rotate the telescope in a downward direction, and upward and downward we know from the angle. So if the angle is positive means station is in upward direction, and if the angle is negative, so station in a downward direction. So here the horizontal distance is maybe either measured or computed. So this line means that we measure the distance by the measuring tape or chain, or we calculate the horizontal distance by using the different formulas, mathematical formulas, to solve the example. Now relative height are calculated using the trigonometric formula. So here there are the main three formulas: sin theta, cos theta and tan theta. These three formulas, trigonometric formula is their main formula. So here by using the one angle and one distance we measure the another distance or find out the another distance. So these are the trigonometric formula. So in an example we very well know about what is trigonometric formula. So if the distance between the instrument station and object is small, so correction of the earth or curvature and reflection is not required. So here curvature of the earth. So in a first year basic civil engineering, so in a plane and geometric survey, so this type of the survey is done. So in a plane survey, distance between the 2 point is measured as a plane line and a simple straight line, and in a geometric survey earth curvature is included, so it's called a curvature of the earth. So here correction of the curvature of the earth is not included in example if the distance between the 2 point are nearer, and if the distance between instrument station and object is large, so combined correction is a 0.0673 d square. So here d is a distance in a kilometer, and for a curvature and reflection is required. So if the vertical angle is positive, correction taken is a positive, and if the vertical angle is negative, so correction we take as a negative. Now methods of the observation for a trigonometric leveling. So here in a G2 examination this type of the question ask like analyze the different method. or analyze the methods of the observation in a trigonometric leveling and explain any one in detail with figure. So here there are the main two types of the observation in a trigonometric leveling. First one is a direct method and second is a reciprocal method. So we discuss about the what is direct method and what is reciprocal method. So here the method is useful where it is not possible to set the instrument over the station whose elevation is to be determined, and to determine the height of the tower, like uh, to find out the height of the tower. So we are not the set the instrument at a height of the tower, but we use the trigonometric formula to find out the height of the tower. So this method to find out the elevated point heights, so we use the direct method. So in this method the instrument is set at the station on a ground whose elevation is known, and if the distance between 2 points is so large, so combined correction, we already discussed the combined correction, curvature of the earth and correction, so included as a 0.0673 d square, and here d is in a kilometer. And second method is the reciprocal method. So in this method instrument is set on each of the two station alternatively, and observation are taken. So here difference in elevation between the two station A and B is to be determined. So first the instrument is set at a point and take the observation of the B, and then the instrument is shifted and set up the instrument at a B point, and then observation done at a point. So this method is a reciprocal method. So now we discuss the another point or a topic which one is important and always ask in a G2 examination, like a method of determination of the elevation of point by theodolite. So here there are the three cases are there. So in these three cases compulsory RL of any point is compulsory required, and there are the main three cases to determine the RL of any point. And like case number one, base of object accessible. Case number two is a base of object inaccessible, and instrument station is in a vertical plane as the elevated object. And case number three is that base of object is inaccessible and instrument station not in the same vertical plane as the elevated object. So like case number one is a base of object accessible. So here we discuss about the base of the object accessible, like a point. This a point show the instrument station, then after see this figure, b point show the point of the observation point or observe point. Now h, small h is elevation from the point B, uh, elevation of B from the instrument axis. So this one is a imaginary line, dotted line show the imaginary line. So when the instrument is set up at a horizontally and vertically at a 0 degree, so we set the horizontal imaginary line, so it's instrument axis, and B point is top point of the elevation point of the observe point, and h is elevation of a B from the instrument axis. Now D, so what is D? D is a horizontal distance between the A point, means instrument station to base of the object. So this distance is a horizontal distance D. Now H1, what is H1? H1 is the height of instrument, H1, this one. So H1 is the height of instrument. So from the bottom point of the instrument to top point of the instrument is called a height of the instrument, HI or a H1. Now BS is a backside reading taken, stop put on a benchmark. So this one is a benchmark and we take a reading at a backside, so it's called a BS. And alpha is an angle which created from the top point of the object to horizontal line of sight or a instrument axis. So this angle is known as a alpha angle BAC. So A dash is a instrument point and capital A is a instrument station. Now from the figure we apply the trigonometric formula. So here tan alpha. So tan alpha is equal to H, means BC is equal to H divided by D. D is a E dash C and AD. AC. Both are same. So value is a D. So tan alpha is equal to H divided by D. H divided by D. So here horizontal distance D we measure with by using the tap or chain, and we find out the vertical distance or vertical height small h. So we simply h is equal to D tan alpha. Clear? Now RL of B point. So here B point RL we require. So B point RL is a RL of batch mark, this one. So we are already known batch mark, and a BS is a backside, this one. Then after we reach at horizontal line of sight and a plus H. So this value. So small h is that. So from the batch mark to B point, uh, elevation or RL we easily known from this formula. So RL of B point is the RL of benchmark plus BS D tan alpha. So H we already discussed, H is equal to D tan alpha, we already calculated here. Now if the distance between the 2 points is large, so curvature of the earth is considered. So here we add the 0.0673 d square. So d is a horizontal distance, this one is in a kilometer, we put at here. So RL of B point we calculate by using this formula. Now case number 2, base of object inaccessible and instrument station in vertical plane as as the elevated object. So here when it is not possible to measure the horizontal distance between the instrument station and the base of object, this method is employed to determine the RL of the object. So here there are the main two cases there. So case number A, instrument axis at the same level, and case number B is the instrument axis at a different level. So first we start instrument axis at a same level. So here there are the two instruments is set up at a point and B point, and both the instruments are at a same level, and instrument axis are at a same level. So this method is instrument axis are same level is a case number A. Now here alpha 1 and alpha 2 both two angle is measured and bisect the P point, means elevated point, and from the also B point we bisect the P point, elevated point, and we measure the angle alpha 1 and alpha 2. Now here we discuss what is A, what is B. So A and B, so is a instrument station, these two are, and A dash and B dash is a telescope point of the particular instrument, and H is from the horizontal instrument axis to the top of the point distance is a small h. Now small b is a horizontal distance between the two instrument station, and alpha 1 is the angle from the top of the point to instrument axis is a alpha 1, and similarly alpha 2 is the angle from the top of the point to instrument axis is a alpha 2, and from the PA dash P PA dash P dash we take this one P A dash P dash. Now we apply the simple and logical trigonometric formula tan alpha 1 is equal to H divided by D. Clear? So tan alpha 1 is equal to h divided by d. So h is equal to d tan alpha 1. So this one is equation number 1. Now from the p b dash p dash, so tan alpha 2, this one, so h divided by d plus b, h divided by d plus b, or a b plus d, both are same. So h is equal to b plus d tan alpha 2. This formula number 2 here. Now equating both the equation 1 and 2. So here equation 1 is h is equal to d tan alpha 1, and equation number 2 is h is equal to b plus d tan alpha 2. So d tan alpha 1 is equal to b plus d tan alpha 2. So d tan alpha 1 b multiplied by tan alpha 2, and d multiplied by tan alpha 2. Now here we common the d value. So d tan alpha 1, here d value is put at here, so minus d tan alpha 2 is equal to b tan alpha 2. Now d we take a common, then after in the bracket d tan alpha 1 minus tan alpha 2 is equal to b tan alpha 2. So horizontal distance d is equal to b tan alpha 2 divided by tan alpha 1 minus tan alpha 2. Now this one is we find out the equation number 3. So this value d value put in equation number 1. So we are already discussed the equation number 1, d tan alpha 1. So here h is equal to d tan alpha 1. Now d value we already calculated from this equation. So b tan alpha 1 tan alpha 2 divided by tan alpha 1 minus tan alpha 2. So these are the horizontal distance equation. H, small h is we are already discussed. So small is a horizontal instrument axis to top of the point is a horizontal distance, vertical distance h. Now RL of a P point. So RL of P point, we find out the RL of P point. So RL of BM plus BS plus small h. So BM and BS we are already calculated. Now case number 2 is a instrument axis at a different level. So here this instrument axis at a different level we discuss in a next lecture. We stop at here. Thank you.